Hello. All right, so expanding on VR as a technology, mine is going to be more like a case study, an example of collaborative VR use on hyperscale data center projects. So introduction for who I am. My name's Taylor Gilmore. I'm an integrated construction director with Mortenson Construction. Basically, integrated construction at Mortenson means VDC and more. So I like that they call anyone in the VDC role as integrated construction, because really, where it's more than VDC, we are the integrator for the project. So I love that they call that on the title, but for those of you that aren't familiar, it's VDC, really, is the capacity that I work in. We have 74 VDC experts in our company and 12 interns with us this summer in VDC. It's our first year having a PhD intern from CIFE join us, so we're excited about that. And then a little bit about Mortenson. We have, let's see, I'm in our data center group. We are a traveling group. There's 2 other traveling groups, federal and sports. We also have 5 energy and infrastructure groups, and 8 geographic groups across the country based in the United States. Look online, Mortenson.com, if you guys want any more information about us. And then today, what I'm going to talk about truly is a little bit of background on what was the problem, the solution, which, spoiler alert, is VR, a little bit of the project outcomes and benefits, and then actually the Q&A we're going to hold till the panel section, so hold your questions. So getting right into the background. So BIM is foundational to the design and construction industry. It's primarily used by VDC experts, so not necessarily available to everybody. You kind of need a supercomputer to be able to run the platform. You need to understand how to navigate in the software, be able to open the software. Not everybody necessarily has access to that. So what that means is that your non-VDC team feedback typically comes too late in a project. Another element of background for the problem is that clash detection is limited. Other issues may be missed. So when we're running clash on a project, it's really looking for elements that are hitting each other in the model, and you may not see other issues that may be impactful to operations of the building. So historically, when feedback's provided, just going a little bit more in detail here, during design, you get your architecture and engineering different backgrounds, looking at the model, getting into the space. They may not have a high level of development, and so they may be missing some critical details, but at least they're in the model, giving their feedback during design. During detailing, then you'll have your trades and general contractors really get in the model. You're bringing it up to that higher level of development. You're adding critical information that you're able to look at. But again, it's limited to just those VDC experts that can get in the model, that do understand how to use the software. Maybe you get some other feedback, but it's over the shoulder of the VDC team driving the show. And so really when you get feedback from everybody during construction, right? Once it's in the field, you go on a job rock, facilities is checking out their new space, and they start pointing out potential issues that they have. May need to be reworked, may just make their job more difficult. So truly, that's history on the background of what the problem is. So as we all know, finding issues during critical operations, very bad. It's the worst time you can find an issue. What that means is if it's something that requires rework, you're stopping operations of the building in order to address it. Most costly, impacts to the building. Another bad time to find issues is either during installation or right after installation, where maybe the project hasn't been turned over yet, but work is in place. You have to tear it out, do rework, costs money, pushes the schedule. Not a good thing. So really, the only good time to find an issue is before something is installed. That's incredibly challenging. Sometimes you might not have your facilities team on site yet because the facility's not there. So when teams are geographically dispersed, when site access is limited, and when the building doesn't exist yet, how do you find those issues? Now this is where VR comes into play. What if you could walk through your project before it was built? So the solution truly for non-VDC engagement, VR is for the masses, right? There's a super low barrier to entry. It's come a very long way since 1996 when Martin was in the cave in VR. You don't need to be tethered anymore. It's, wireless, pop it on. If you can play a video game, you can get in VR. You don't need any special training. You turn it on, you put it on, you open the app, and it's super easy to navigate. The Resolve software is something that 5 to 10 minutes, you know what to do, you're off exploring your project. It drives earlier feedback. So prior to actual construction, we're getting our facilities teams or other stakeholders in the model able to provide comments and give us feedback that potentially changes design or at minimum changes small things so that they're able to operate their facility better. It's a simple technology, like I said, there's no computers, it's really easy to get set up, 5 to 10 minutes of quick training to understand how to navigate, take some measurements, add comments, and you're good to go. And I think probably the most powerful feature that we've seen in Resolve is that it's multi-collaborative, like you're all in the same model at the same time versus like a standalone one user in the space in VR. You have multiple participants. So we've been treating them like a typical job walk where you can have many diverse backgrounds, everyone's in the same space, everyone can hear each other. You can mute yourself when you don't get background noise, but you turn on your microphone if you have a comment. It truly is a means to have everyone immersed in the same space. Treat it like a job walk. You don't have to. You can also have one-off sessions where people are walking and exploring on their own. The comments are tracked and collated, and it doesn't have to be set up like a job walk, but we make sure to have those touch points with everybody and are pointing out issues. They are encouraged to explore on their own. There's functionalities with Resolve where you can gather everyone to the same spot so that you're looking at the same critical issue if there's something that comes up. So truly a powerful tool. Another great thing about Resolve is that it ties in to kind of our standard processes, and it can be utilized across the entire building life cycle, reducing the risk and cost of changes. So from design to the BIM detailing, even to right before construction, you can walk through the space to either find potential risks or to see what's planned, what's supposed to be in place, help understand the sequencing. It helps all parties involved align on outcomes and surface potential risks early on so we can resolve them without big impact to the project. Like I said, it ties into some of our standard processes. We use BIM 360, now moving towards ACC to host a lot of our models, and we're creating federated models for clash detection already. So it ties into those same federated model file types. So we'd upload that to BIM 360 or ACC, and then Resolve has a direct integration with that, so you're able to link it, and then it's available in the platform. Super easy, not a ton of extra work. And then obviously those quality improvements that are made to the model, pull back in, update the file, and you're able to re-walk through the site. So more of an iterative process compared to traditional, maybe construction models. And here's just a quick snapshot of some results from a single data center project. Keep in mind, these are very, very massive projects. It's almost 1 million square feet of building in a single complete build. I think that's about 90,000 square meters for those of you in metric. And in this one project, over 600 issues were raised. We categorized those in order of importance. There's some that are trivial that we wouldn't review as a group, and then some pretty high impactful ones. So out of those 600 issues, there were about 50 that were critical that needed to be resolved that may not have been caught during clash detection. It wasn't 600 issues all at once. Similar to our coordination process, we'll kind of break up the building into chunks when we're reviewing, but Resolve is really powerful in that it can handle those really massive, large file types It has some built-in tech that I don't understand, but essentially it simplifies the geometry that's farther away, so it's able to handle a large file size. When something's closer to you, it's in that higher level of detail, so you're able to really see what you're looking at right in front of you. What's interesting here is it spanned across 4 different states of engagement, and then also there were 50 headsets used for those virtual reviews on this one project. This is a pretty typical example of an issue. Just to share some context, these conduits in the IDF room were very high in elevation, and there was MEP systems below that obstructed access to these step-outs. So the owner will come in and install things, their own stuff after. They have their own teams that deploy. And they wouldn't have been able to access this. There was stuff in the way. It would have required us to remove some of the systems that have been installed in order for them to come and access it. And they were made more accessible by adding 90 stub downs. Estimated construction cost savings was about $12,000. Not a huge issue in terms of the size of the project we're dealing with, but think about 600 plus issues and varying levels of cost impact. And then the operational risk avoided here was those conduits would not have been accessible for the operations team. So a quick summary of the benefits of this collaborative VR platform. Improved collaboration between all the different disciplines. We're firm believers that the more diverse perspectives you get, the more diverse, stakeholders that are looking at things, then the better the outcomes are going to be, the more risk is going to be mitigated. There's a reduction in the construction changes and cost of ownership to the client. A reduction in facility operations and safety risks. One example that comes to mind when we're reviewing with our facilities team, in our water treatment rooms, there were pot feeders that contained sulfuric acid and an eye wash station, right, just in case. So what they realized in this immersive VR environment is that if they happened to get acid on their eyes, then there were obstructions with ramps that had railings. They'd have to try to navigate around to get to the eye wash station in the room. So we were able to relocate the eye wash station so that their path of travel was not obstructed from the pot feeders to the eye wash station. So again, really mitigating some safety risk there for the operations team. And then finally, improve sustainability with a reduction in construction waste. Rework is waste. So we want to make sure we avoid that. And I'll leave you with one more just note. I think when you're in VR, you are immersed in it. So it's a different perspective, right? Sometimes it takes a different perspective at looking at an environment. You might not catch something during the clash detection. You have a lot of diverse perspectives looking at something, and it really eliminates all the distractions. You can't be on your cell phone texting. You're in the space, you're committed, you're giving your feedback, and it provides a lot of benefits for everyone involved. And we'll save questions for the panel. Thank you.